In this video I was trying to make some cool stuff in the 3D world and I ended up making my own camera system. Here's the timestamps if you're looking for a specific part, but trust me, the more you know about them, the more satisfying they become. Enjoy the process and don't miss the final result. Hey, this is P5.js, welcome to my video. Let's start working with some 3D stuff, shall we? I'll start with a white box, a black background, and orbit control. Let's see. Yeah, it's a good platform to start with. Let's add some lines to see the perspective a little bit better. Okay, yeah, now it's better. Let's add a sphere too. Here's the sphere and it looks pretty good actually. But look what happens when I get close to it. It looks really amazing. Let me explain what is happening. This is my camera and this is the field of view. As you can tell, there's a minimum and maximum range for what my camera can see. So if we consider these shapes on the screen, we can only see the middle one because the others are just over the limit. But let's get more precise. If a sphere is getting away from the camera, it gets smaller and smaller and eventually it disappears. Just like this. It affects the box too. But getting closer is a little different. We can see a hollow open half sphere. It's like we can cut it open and see it inside. So now we can have multiple spheres into each other and see all of them at the same time. An effect that doesn't seem to be achievable in the real world. Let's get some light in here. This is actually so classic, I want to have some more real lightening for it. Okay, look at this now. We have reflections, which are coming from the actual sun over there. You can see how big and far it is compared to our little platform. Actually, the sun is not the light source, it's just a dramatically big and far away sphere that I had to extend the maximum range of my camera to be able to see it. So where is this reflections coming from? It's just something called specular material. Every 3D object has something called material, which means how much it should reflect the light around it. This box distributes the lights around it. We can't see a point of light out of it. But this box can show us a point of source light, which means this box is shinier than this one. So now we know how the shininess affects our shape against the directional light. But if you look carefully, you can see that the specular material gets a color. What does that mean? Well, in the real world, the reflected light is always relative to the source light. But in the digital world, we don't have that limitation. We can get any reflected light out of any source. You can see here I'm getting a green reflection out of the orange sun. Is that cool? But let's talk about the camera movement. The P5.js camera moves like the camera in Blender. The lens is locked to a certain point. There's ways to move that point, but it's pretty useless when you're trying to work with a larger scale. And that's why the game engines use a first-person camera to let you navigate the whole world pretty fast and easily. Guess you know what I'm gonna do. You know, I could show you everything with just some vectors and stuff, but I want it to be more fun. Okay, I guess we're done. Have some logos and a little recording screen right here. Now let's use our model in P5.js. Here's the object and the PNG as a texture. And here's how the syntax works. We load them in preload function, we apply the positioning and render them after all. Here it is, the ultimate personal camera. Looks beautiful, I'm not gonna lie. Here's the camera structure. We have a camera position and a target position, which the camera is looking at. And by default, P5.js moves the camera relative to the target. We can go left and right, up and down, back and forth, but the target doesn't move. But we want it to be other way around. We want to move the target relative to the camera. In the 2D version, the only things we need is an angle and distance. But in the 3D world, we have two angles. As you can see, we have position, horizontal angle, and vertical angle. In that way, we can calculate the target position to render the camera. And changing the angles by the mouse movement is not a hard thing to do. So the only thing left is the actual movement, which we can do by the keys we press and the actual angles. Now that I have a free camera, I can make many cool simulations in the future. So make sure to subscribe so you don't miss them. And if you got any cool ideas in your head, share it in the comments, I will check it out and maybe make it real. And as always, keep yourself hydrated. Maybe you're wondering why I always say don't try at home. Well, this is what happens. I failed this one. Peace. Bye. Oh.